Let's look at the question for today taken from A.C.Curcuit in physics. And we are to show that IRMS equals I peak divided by the square root of 2 with respect to alternating current. So let us go to the class. All right, from the question we read earlier on before we came to the class, we are to show or prove that root mean squared current is equal to peak current of an alternating current. That's what they want us to find. When you look at a question that has to do with proofs, most of the times the proofs in physics are condensed to the basic understanding of what they have taught you before. So you have to, alternating current possesses sinusoidal function like every other wave, all right? It looks like wave, it behaves like wave. So we recall that for all waves, all right, we were told that the displacement along the vertical is equal to the amplitude times sine, angular velocity times time. I mean, this is very popular equations of wave. This is from the first point of the establishment of sinusoidal function of equation of wave. So this is common. Now we want to write this, all right? We want to write it in terms of current. So the current that is displacing along the vertical is equal to maximum displacing current. Then we have sine omega t, and you can get that if you have this sort of illustration. Here is the vertical axis. I is around this side, which is the same thing as the y-axis. All right, so as the wave is moving, all right, the wave is moving angularly like this. The time is also changing. So if a particle of the wave is spotted at a point, it would have moved angle theta away from the origin. So this is the maximum amplitude. All right, so if we draw a straight line down, we're going to have something that looks like this. So this is the phase angle, and then we have this as the radius. All right, then we have this as the y. This radius is also referred to as the amplitude. That's the maximum displacement of the wave from the point of equilibrium. So if you establish relationship between these two parameters, what we're going to have is the first equation that we have got. That means that we have y over amplitude is equal to sine theta, and theta is equal to omega times time. So our y is equal to amplitude, then sine omega theta. I mean, this is the equation. In the same way also, if you change it and then you have the maximum current here, and then you have current displacing along the vertical, to write that of current is going to be current, all right, equals peak current, then you have omega d. So this equation is very important for us in our proof. You just apply very simple mathematical ideas and then you're good to go. So square both sides. So we square both sides of this equation. We are going to have I squared equals I peak squared, then sine squared omega times time. So for one complete circle, for a complete circle, for a complete circle, the value of sine squared omega theta, this value, sine squared omega theta is approximately equals 0.5 or half. So if that is the case, it means that we now have our I squared is equal to I0 squared times 1 over 2. I0 squared. So we have I0 squared times 1 over 2. So if we find square root of both sides, all right, square root of both sides, I squared equals square root of I0 squared times 1 over 2. So if you compute the equation, the first one is the one we call the root mean squared value of the current, and is equal to peak current divided by the square root of 2, which is what we are asked to prove. I hope it makes sense. Physics is fun.